Welcome to the presentation of AI Agent Workflow for Reviewing AI-Driven Sperm Assessment Literature. This presentation is delivered by Viet Trinh, An Pham, Hung Tong, and Tan Huynh Tran. The authors are affiliated with the University of Economics and Law and Vietnam National University, located in Ho Chi Minh City, Vietnam. In vitro fertilization, IVF, stands as the most widely adopted technique in assisted reproductive technology for treating infertility. A critical initial step in evaluating reproductive health involves analyzing spermatic health, which encompasses sperm concentration, motility progressiveness, and morphological abnormality. Despite recent advancements in artificial intelligence, AI, have introduced new possibilities for more accurate and efficient analysis, challenges persist due to fragmented data and localized developments of AI models that address only specific spermatic objectives. Therefore, a systematic review of the existing literature is necessary to consolidate current knowledge, identify research gaps, and propose standardized approaches for future research in this vital field. This study introduces an innovative AI agent workflow specifically designed to systematically review and summarize over 50 relevant research publications in the field of AI-driven sperm analysis. This workflow has demonstrated effectiveness in accurately classifying studies based on their focus, distinguishing between single-objective and multi-objective research. The classification is based on important criteria such as sperm concentration, motility progressiveness, and abnormal morphology. The proposed AI agent workflow is intended to serve as a foundational tool for future literature synthesis across diverse domains of knowledge, offering an innovative, scalable, and efficient research methodology. The proposed approach for systematically reviewing AI-driven sperm assessment literature is generally illustrated in the figure. This work involved collecting open-access research publications related to semen analysis from the past 20 years, sourced from a variety of reliable publishing platforms. After a rigorous filtering process to retain only the most relevant papers, an AI agent workflow, developed using the popular N8N platform, was deployed. The main function of this workflow was to extract crucial insights from the collected papers and to classify each publication's research intention. The data collection process for this literature review strictly adhered to the PRISMA 2020 guidelines, ensuring transparency, integrity, and reproducibility of the research. This collective set of open-access research papers was accumulated across 5 major publishing sources: PubMed, IEEE Explore, Scopus, Web of Science, and AR14, with a focus theme on sperm analysis within assisted reproductive technology. The search query strategically combined AI-related terms such as artificial intelligence, deep learning, and neural network with keywords related to sperm parameters, including sperm concentration, morphology analysis, motility progressiveness, sperm detection, morphology segmentation, sperm vitality, and semen analysis, to identify the most relevant studies. As a result, a synthesizing collection of 52 relevant works, stored in PDF format in Google Drive, was then fed into the AI agent workflow for classification as either a single objective or a multi-objective evaluation, with objectives categorized as concentration determination, motility trajectory, and morphology analysis. The AI agent workflow was meticulously developed using the N8N platform, which uniquely integrates AI capabilities with business process automation, offering the flexibility of code-based customization alongside the efficiency of no-code development. In this research, the AI agent workflow operates through a precise sequence of steps. It first retains only the text-based content after a pre-processing scan of each research paper in its PDF format. It applies optical character recognition and natural language processing techniques to classify a study as either a single objective or a multi-objective focus. Finally, it generates a structured summary of each paper in a tabular form, providing insights into the underlying deep neural network, the experimented dataset, and specific research objectives. For each input study, the agent workflow performs one execution, processing approximately 18,500 tokens end-to-end. Collectively, the entire dataset in this research necessitated 52 executions, totaling 1,426,317 tokens, and it was interesting to note that the workflow's outputs reasonably aligned with a physical review conducted manually. The figure demonstrates the recent trend in employing AI technologies to evaluate sperm vitality, highlighting significant shifts over time. Early works in sperm analysis predominantly focused on calculating sperm concentration within a semen sample. A notable surge in AI applications within biomedical imaging emerged around 2019, which was likely driven by significant advancements in deep learning technologies. Among these, the VISM dataset emerged as the most frequently utilized dataset, being cited in more than 16 studies related to sperm motility and morphology. Since 2021, further advancements in YOLO-based architectures and transformer-based variants have enabled more sophisticated spatiotemporal analysis, facilitating an increasing capability in tracking sperm movement and accurately determining motility progression over time. For the sole objective of calculating sperm concentration, the AI agent workflow successfully identified 7 relevant studies. These studies predominantly featured a CNN-based model as their underlying architecture for sperm detection. Additionally, the workflow induced that the datasets utilized in these studies were mostly private, suggesting a need for more publicly available resources. Advanced object detection architectures, such as CNN or cutting-edge YOLO, have significantly improved sperm detection accuracy, even within complex microscopic environments. For the single objective task of rating motility progressiveness, which categorizes sperm as fast progressively motile, slow progressively motile, non-progressively motile, and immotile, the AI agent workflow pointed out that CNN and YOLO continue to be favorable network choices. Furthermore, the VISM dataset emerged as the most frequently utilized experimental dataset for this specific objective. Unlike the concentration objective, which primarily involves counting visible sperms in a single image, motility rating necessitates the tracking of sperm movement across consecutive frames of an input video. Consequently, a traditional CNN-based network must be coupled with a modal tracker, such as SORD or JPDA, to accurately diagnose a motility trajectory. YOLO's inherent ability to process images at high speed and identify objects with high accuracy makes it a prime candidate for integration into any tracking system. Unlike the other two objectives, morphology analysis has garnered significant interest within the research community since 2017. The AI agent workflow specifically determined that there are 26 studies focusing on morphology segmentation, with the primary aim of detecting abnormalities in the sperm head, midpiece, or tail. It is undeniable that analyzing sperm morphology presents an exceptionally challenging task, as it requires accurate instance segmentation of microscopic-level images, where the delicate tail section is often almost interwoven with the background. Therefore, sophisticated neural network architectures or hybrid models are expected to become the norm for effectively solving this complex task. Coincidentally, this AI agent workflow also identified complex models such as ensemble, SWIN transformer, DenseNet, or EfficientNet2 as dominant approaches across different datasets for morphology analysis. Due to the fragmented nature of existing human sperm datasets and the localized development of artificial intelligence models for evaluating sperm reproductivity, this study successfully introduced an innovative AI agent workflow. This workflow was specifically designed to semi-automatically review the literature on AI-driven sperm assessment, addressing a critical need in the field. The proposed workflow effectively processes each research publication, accurately identifies its underlying neural network architecture, and precisely classifies its assessment objective. As a significant result, this AI agent workflow identified a total of 7 multi-objective and 45 single-objective research publications. Breaking down the single-objective studies, it found 7 studies focused on sperm concentration, 12 on motility rating, and 26 on morphology analysis. This AI agent workflow can serve as a foundation for future literature synthesis across different domains of knowledge, offering an innovative, scalable, and efficient research methodology.